Project page 3, patterns and sequences. Please notice that this says project page 3, so this is a set of notes that you are going to need to make sure that you take good notes on and hold on to until we actually collect all the project pages at the end of our review. Now, for this one, we are talking about patterns and sequences. Now, a sequence is a list of numbers that forms a pattern. For example, 3, 6, 9, 12, and even if it continues, that is a sequence. And it's a sequence that forms a pattern because the pattern is that we are adding 3 each time to get to the next number in our sequence. Now, if I asked you what is the third term in the sequence, well, in this problem, each number in a sequence is called the term. So if I asked you for the third one, 1, 2, 3, the third term is 9. That's all it means. So let's take a look at example number 1. This one asks which equation identifies the pattern shown in the table. So if you look at the table, you might not be able to tell if that guy is linear, quadratic, or exponential, so using StatEdit might not be the best way to go. So if you're not sure which one of those it is, use this other method. Go to y equals on your calculator and type in the first answer choice. What I'm going to do is scroll over on my table, I press second graph, and I go to my table, and I look for this point. Now, -1, -15 is not on my point, or on my graph. So I'm going to mark out answer choice A, and then check the next one. So this one has -x, I press second graph. That one definitely does not have the first point on my table right here, so I'm going to move on. And then x minus 10, press second graph. This one has -5, -15, so it has the first one, but you need to make sure it has all 4 because they like to try to trick you. I've got 0, -10, 7, -3, and 15, 5. So that one did have all of those points on this table, so it is the best answer. Now, it looks like my example numbers got off a little bit, but we're going to go ahead and move down to example number 3. It says the table shows Jason's weekly earnings during the last 4 weeks. Which of the following equations best describes the relationship between H and the number of hours that Jason worked and W, his weekly wage? Now, the only difference on this one is that our equations use W and H instead of X and Y, but that doesn't actually matter if you read what I put right here. Even though we don't have X and Y, we can still just use our calculator. So I'm going to do this one the same way. 5.50, and I've got x squared. Let's press second graph. So I'm going to start with this 10. I should have 1055, but I've got 10,550, so answer choice A is out right away. If I check B, I've got 5.50x plus 10, second graph. It's got 1065, it's out. Then if I check the next one, 5.50x plus 1, so let's get rid of that 0 and press second graph. Now I've got 1056, so it's not that one. Let's try the very last one, second graph. When I do this one, I've got 1055, so that one worked. Let's go back up to 8. I've got 844, so that one does match. If I scroll on down to 15, that one's got 82.5, which does match up. And then if I go down to 17, 9350. So D is the best answer. Okay, now let's go on up to example number 2. What equation describes the 4 ordered pairs -1, -1, 0, 1, 2, 5, and 3, 7? This is the exact same type of problem as what we were just doing. When they give you a list of ordered pairs, that is the same thing as a table of x and y values. So I'm going to go to my calculator, go to y equals, and I'm doing 2x plus 1, and I want to start back at 0, so let's start there. So I've got -1, -1, it has that first point. It has 0, 1, that's the second point. And if I keep going, it has 2, 5, and it has 3, 7. So we got lucky on this one. Every single one of those ordered pairs matches up with answer choice A. Number 4. Which expression can be used to find the value of the term in the nth position? When they say the nth position, they're just meaning, hey, if you plug any number into this equation, what number are you going to get? So they're basically asking us for the formula of this equation. Now, I'm going to go in and do the same thing that we've been doing on all the other ones, and I'm doing x divided by 2 instead of n divided by 2. And if I press second graph, the first thing I notice is that I've got 1, and then I've got a fraction instead of a decimal, and 1/2 is the same thing as 0.5. So why did that happen? Well, if you type a fraction into the y equals, like x divided by 2, you're going to get a fraction answer whenever you have the y's on the table. But if you typed in something else, like if I typed this in as x divided by 2 as a decimal, or as a division problem, then it's going to actually give me the decimal answers. Now you can do that, but it does kind of start to become a little bit confusing, especially with answer choice C. So what I would like for you to do instead is go to the table over here and type in 0.5, and let's change that back to a fraction. So I'm going to press the math button, and then I press enter, enter. And when I do that, I get 1/2. So I'm just going to make some notes over here. This is the same thing as 1/2. If I do 0.75, math, enter, enter, that's 3/4. Now that 1 is fine, so I'm going to leave it there. But then 1.25, math, enter, enter, is 5/4. And 1.5, math, enter, enter, I've got 3/2. So now I'm going to go back to this equation. Let's get rid of this. Second graph. Now let's see if they match. So I've got 1 and 1/2, so that one's okay. I've got 2, and then I have 1. So automatically answer choice A is gone. For answer choice B, I've got 3x divided by 2, second graph. If I type that one in, I've got 1 and then 3/2, so it's out automatically. And part C, this one has x plus 1 on the top divided by 4, and I would press second graph. So this one has 1, 1/2. It has 2, and then it has 3/4. It has 3, 1, 4, 5/4, and finally 5, 3/2. That is the best answer. Now the reason that I did not tell you to just do it as a division problem is because look what happens if you do x plus 1 divided by 4, and now look at this. These numbers aren't even remotely the same thing. And why did that happen? Well, what you should have done if you were going to type it like this is do x plus 1 divided by 4 like that in your calculator, because you want it to do x plus 1 first and then divide by 4. Then you can see that those are actually talking about the same numbers. Example 5. Which algebraic expression best represents the relationship between a term in the sequence below and its position in the sequence? Now remember what I said about the front. A sequence is just a pattern of numbers, a list of numbers forming a pattern. But if you look down here at what I wrote, it says a sequence is really just the y values of a table. So I'm going to make myself a little table. I've got x and y right here. These are my y values. So it's 0, 3, 8, 15, and 24. Now, as far as what we're going to put for the x values, we're just going to start numbering them with 1, 2, 3, 4, and 5. And from here, it is the exact same thing as all the other problems that we have been doing. So I'm going to clear my calculator and type in the first answer choice, x minus 1. So I have 1, 0, but I don't have 2, 3, so A is out. Then if I do x squared minus 1 and press second graph, I've got 1, 0, 2, 3, 3, 8, 4, 15, and 5, 24. That one had all of my numbers, so it's the best answer. Number 6. Mrs. McCutcheon used identical square tiles to design the 4 figures shown below. Which expression can be used to determine the number of square tiles used in each figure if n represents the number assigned to the figure? So the same way x is talking about the numbers, that's what n is talking about. First figure, second figure, third figure, fourth. Now, since we are asked to determine the number of square tiles, that's the numbers that we are going to put on the y side of our graph. So this is my x values, this is my y values. We've got figure 1, 2, 3, and 4. My y values, I'm going to count the squares. Well, I've got 3 squares in figure 1, 4 in figure 2, 1, 2, 3, 4, 5 in the next one, and then 6 in the last one. So now, once I've got my table all set up, I'm going to go to y equals in my calculator and type in the first answer choice. All right, I've got 1, 3, but then I have 2, 6, not 2, 4, so it's out. Okay, x squared plus 2, second graph. I've got 1, 3, and then 2, 6, not 2, 4, so it's gone. Then I do 2x plus 1, second graph. I've got 1, 3, and then 2, 5, so it's gone. And finally, x plus 2, second graph. It has 1, 3, 2, 4, 3, 5, and 4, 6. It had every single one of those points, so it works out. So now we are getting up to example number 7, and this was one of those questions that was on your benchmark that quite a few people asked me about. It says, in a sequence of numbers, a sub 3, so when it's a little number like that, it's called a sub. So a sub 3 equals 0, a sub 4 equals 6, a sub 5 equals 12, a sub 6 equals 18, and a sub 7 equals 24. So based on this information, which equation can be used to find the nth term in the sequence? So basically, what can we use to represent the numbers in our sequence? Now it says, when they're giving you a to the n, the letter n stands for the position in the sequence. So this is basically us creating our own table again. But instead of numbering 1, 2, 3, 4, 5, I'm going to look at the little number that they have right here. The n number, a sub n, like that, that is your x values. So it's 3, my y value would be 0. If I plug this one in, I've got 4, 6, 5, 12, 6, 18, and 7, 24. Once again, as soon as you have created your own table and they gave you a bunch of equations, you can just plug those in and press second graph. So I've got 3, 0, and then I've got 4, negative 6, not positive 6, so it's gone. Negative 18x plus 6. This one has 3, negative 48, so it doesn't even have the first point, it's gone. 6x minus 18, second graph. So I have 3, 0, 4, 6, 5, 12, 6, 18, and 7, 24. It had every single one of those, so C is the best answer. Now this last one is really the trickiest one, and this is one of those sequence questions that showed up on the STAR test a couple of years ago. It says a sequence can be generated by using this, which looks like a whole big mess, but I have broken it down for you over here in this little box. But they said a sub 1 equals 6, and n is a whole number greater than 1. So what are the first 4 terms in the sequence? All right, when you see this, 4a and then n minus 1 as my little sub, it means take the previous number in your sequence and multiply it by 4. And when they tell us a sub 1 is 6, they're saying the first term in our sequence is 6. All right, so if I did 6 times 4, we are looking at 24. And if I continue this pattern, I'm just going to do the rest of them because they wanted the first 4 numbers. If I multiply by 4 again, I end up with 96. And if I multiply by 4 one more time, that gives me 384. So the first 4 terms of my sequence is answer choice A.